Hi, this is Alex from devstories.eu. GeoPandas, episode 4 of 11. Sometimes the shape you need to analyze is not the shape you were given. You might import a list of store locations as single points, but what you actually need to understand is the delivery area surrounding them. This requires mathematically molding points and lines into dynamic boundaries using shaping space, buffers, centroids, and convex hulls. These constructive geometric manipulations act like the molding clay of spatial data. You start with raw geometries and use these built-in methods to compute entirely new shapes tailored to your analysis. In GeoPandas, these methods apply element-wise across the entire active geoseries. If you have 10,000 shapes, one command generates 10,000 new ones. All of this relies on the Shapely library under the hood to perform the geometric math. The most common manipulation is the buffer method. A buffer creates a polygon representing all points within a given distance from your original shape. Take a scenario where you have point geometries representing coffee shops. You want to define a 2-kilometer delivery catchment area for each location. You call the buffer method on your points and pass in your distance. GeoPandas instantly draws a circle around every single shop, transforming your point dataset into a polygon dataset. Pay attention to this bit. Performing a buffer operation requires a projected coordinate system. If your geometries are in a geographic format like latitude and longitude, a distance value of 10 means 10 degrees, not 10 meters. Because degrees of longitude shrink in physical width as you move away from the equator, buffering unprojected data results in heavily distorted, stretched ovals instead of uniform circles. Always project your data into a metric system before computing distances. Sometimes you need to collapse a shape instead of expanding it. If you have complex polygons representing neighborhood zones and you need to reduce them to single points for distance calculations or map labels, you use the centroid attribute. The centroid calculates the mathematical center of mass for each geometry, returning a perfect central point for every polygon or line in your dataset. To isolate the edges of a shape, you use the boundary attribute. If you have a polygon representing a county, the boundary strips away the entire interior. It returns a lower dimensional geometry, transforming the polygon into a set of lines that just outline the county. If you call boundary on a line, it returns the single points at each end of that line. This is where it gets interesting. You also have the convex hull attribute. Picture a scattered collection of points representing individual animal sightings in a forest. If you were to stretch a rubber band completely around the outermost points and let it snap tight, the shape that rubber band forms is the convex hull. It returns the smallest possible convex polygon that encloses the entire geometry. It is an incredibly fast way to compute the overall physical footprint of a dispersed set of coordinates. Constructive geometry means you are never stuck with the spatial boundaries you imported. You can always compute the exact zones your analysis actually demands. Thanks for spending a few minutes with me. Until next time, take it easy.